So we have to first figure out the analog. The proper analog of the setup. So the function is defined now on the whole xy plane. And what is going to be a reasonable analog of that interval? Well, actually, we just consider a region, some region on that xy plane. You limit our consideration to something, I'll call it D. And then on that D, the function behaves some way. But the problem is that the minimal of a function over the whole plane may not happen inside the region. Right? If the graph is takes high values over the region and then gets very low outside the region, then minimal should happen, well, can happen outside, but still on the region there is a minimum. So we just have to find it. And again, it may happen at some critical point, so we still find critical points. By solving the equation derivative equals 0. And then we analogously disregard those points, those possible critical points outside of the D. And for those inside, just remember all of them. We will evaluate the function at those points. We will compare the values. Now the real problem is not about critical points. The real problem now is looking at the boundary. Because the boundary is not simple anymore. It's not just 2 points, it's the whole curve. How can you evaluate a function on the whole curve? Well, you cannot. There are infinitely many values to take care of. So that step is to be replaced with finding minimum of the function f on the boundary. Okay. And we did it sometime in the past, right? I gave you a curve and I asked you to find the minimum of a function on that curve. Was it the problem of the second test? The longest, the most complicated problem? Minimizing a function on a given curve. So it's doable, but it's not, it is conceptually more difficult than just evaluating a couple of values. But once you do that, you're done. So you find minimum on the boundary, that's a number. You evaluate the values on the critical point, on all the critical points inside D, a bunch of numbers, you compare all of them, take minimum. Now the natural question is, well, why would anybody want to limit in such a complicated scenario? Should I address that question? Or are you already convinced that this is an interesting problem? Well, interesting in sense of reasonable. That may show up in practice.